Excellent, merci. All right, so let me start out by telling you a little bit about myself. Like I said, my name is Elizabeth Porter, and I am a French teacher. That's the way that I identify my job first and foremost, but I wear a lot of hats. The first is that I'm a French teacher. I'm a curriculum specialist in English language arts, social studies, and world languages. I'm a linguist, so I have a degree in linguistics. I am also an education admin with a specialty in performance-based learning. And when I say performance-based learning, in the education world, we encompass that with project-based learning. So I'm going to talk to you about project-based learning, but specifically about neuroplasticity and how project-based learning helps our brains grow and change. So today, I'm going to speak to you about the brain itself, the anatomy of the brain, and I might even pull out my snazzy brain to share with you. And then next time in August, be sure you sign up for August, because I'm going to talk to you in August about the neurodiversity and how our brains learn differently and how we can best serve our children through the way that they learn naturally. So let's get started. I had a little too much fun with my Bitmojis this morning. So let's talk about the brain. The human brain is incredible and amazing. It is an organ, and it's the only organ that does not store its own nutrients and oxygen. However, it uses 20% of the body's resources. So if anybody has ever felt brain fatigue or just that type of fatigue or tiredness where you're just like, oh, I just can't think anymore, that is because you're on what's called sensory overload. Your brain is using way too many resources in your body, and it's like, I need to rest now. And eventually, if you keep going, your brain will automatically say, I need a break, and make you take a break. The brain is the only organ in the body that can grow infinitely. So all of your other organs in your body, your liver, your heart, all of those, they reach the size that they're going to be when you reach full maturity. And that's about between the age of 18 and 25 years old. The brain is considered mature when you are about 25 years old for men, for males, and for women and for females, it's about 21 years old. However, that doesn't mean that your brain stops growing. The reason why it's all wrinkly is because it folds in on itself. Every single time you learn and reinforce a new skill, your brain grows gray matter, and that's called myelination. That's your brain growing, and it just grows and grows and grows and grows. So you only have a finite amount of space up here in your skull. However, the brain adapts and is able to use more of its surface when you learn new skills. The prefrontal cortex, which is this front part of your brain here, this part is the youngest part of the brain. It's only about 3 to 4 million years old. The oldest part of your brain is down here, and it is way older. This is what we call the reptilian brain down here, and it houses the amygdala, which we're going to talk about in just a second. So we're going to talk a little more about the anatomy of the brain. So the lower brain is called the reptilian brain, and it houses what's called the amygdala and the reticular activating system. The reticular activating system, I like to think of, is kind of like the security guard at the gate of your brain. So we know that when you receive information to your brain, it comes in through your senses. What are your senses? We have 5 of them, right? Remember back to kindergarten when you're learning about your 5 senses? Touch, taste, hearing, smell. Oops, I went to the wrong one. Touch, taste, hearing, smell, and sight, right? So those are our special sensory receptors. And what happens is your brain only accepts about 1% of the sensory information that actually comes into the brain because it has to conserve resources. So when I talk to teachers and when I talk to parents, I always say, do you ever have a time when you're talking to your kids or your students and it just looks like they just are not paying attention to you and they're not listening and they're kind of like that? That's because the reticular activating system is rejecting the information. That's why the more of our senses we use, the more information actually makes it through the gate and into the brain, right? So, for example, if you have a child who has to fidget or draw or doodle, like for example, I always have to doodle while I'm listening. And that's because I can pay better attention when I'm activating my kinesthetic learning or my touch sense. Okay. So a lot of times if you see a kid doodling and you're talking to them and they're doodling, that's them helping them pay attention to you. Okay. So don't always say, stop what you're doing and look at me, because sometimes a child needs that in order to actually hear the information and have it enter into the brain. Once the information enters the brain and is accepted by the reticular activating system, which is located down here in the brainstem, right down in here in the brainstem, if you can see that. The next place it goes is to the amygdala. Now, the amygdala is like your watchdog, right? The watchdog of your brain. It tells you whether there is a danger. Now, the amygdala was really, really important for those prehistoric humans who were out on the Serengeti being chased by saber-toothed tigers. And unfortunately, the amygdala has not evolved too much past that point. So the amygdala is our fight or flight response. It's what sends adrenaline. It sends a message to the hippocampus to release adrenaline. Okay. So if a person has a very, very high anxiety, they're going to do what I call living in their amygdala. And so there are ways to help students and children who have anxiety, to help them brighten up those upper levels of their brain and relieve the amygdala. The other thing that happens in the amygdala is that when a student feels or a child feels discouraged, doesn't feel like they can be successful, the skill doesn't move past the amygdala. I have a perfect example of this. I had what I call a learning trauma when I was in first grade. And it was in math. I was given timed tests for math. And those of you who know me and have heard me speak before know how I feel about testing. Testing is not in my vocabulary anymore. In the book, I wrote a book called The Performance-Based Solution, and in the book I talk about how much I dislike testing and how it needs to go. Anyway, students and children with high anxiety, testing will never work for them because every time they get into a testing situation, they will stay in their amygdala. So what happened to me was I was given timed math tests and I struggled with math. And basically, I failed every single time, and I was never given the chance or the confidence to move past that. And as I moved up in the grade levels, I was constantly pushed down. I was constantly struggling with math, and nobody ever did anything that helped me move out of my amygdala and look at math differently and look at math the way that my brain works. And so here I am. I'm about to tell you how old I am. Here I am, 40 years old, and I still have severe math anxiety, to the point where I hired an accounting student from the university to teach my middle school son math, because I am so anxious about math. But the good news is that if we understand the way that the brain works, we can move beyond this. We can help our children move beyond the amygdala. And teaching French, I especially feel that this is important, because language is another area where students struggle and have a hard time moving out of the amygdala. And so we need to find ways that are brain friendly. And that's what we do at Bon Voyage World Languages Academy too, is we apply a brain friendly method of teaching language. So the next part is the upper brain. Now, the upper brain is the newer part of the brain. It's the brain that grew out of, as we as humans evolved, the brain grew, and it grew these different areas. And this is called the cerebral cortex, this whole area here. So all of the area that you see in orange, blue, pink, and green as the cerebral cortex. Oh, let me put my slide. Okay, so we have the brain stem down here. Sorry, the frontal lobe is right up here in front, and it houses the prefrontal cortex. And this is the area with the highest order thinking skills. This is the area where the executive functioning happens. This is where you make your decisions. This is where my slides are jumping around here. Goodness. This is where you make your decisions. This is where you develop reasoning skills. This is where your temperament comes out of. This is where you develop empathy. So all of those higher order thinking skills are housed in the prefrontal cortex. And the more that we grow our prefrontal cortex, the less we live in our amygdalas. So for example, I have a very, very good friend, my best friend, actually. We've been friends since we were 4 years old. And in 2001, he was in a very severe car accident where he was driving from Chicago to Seattle, and he was in Wyoming, and a logging truck lost a log and went straight through his windshield and hit him. And he is very, very lucky to be alive. And I get teary thinking about this, because he is like a member of my family. He and I are very, very close, and he lost a portion of his prefrontal cortex. And so he has what's called a traumatic brain injury. And depending on where that traumatic brain injury happens, you're going to have lower functioning in that part of the brain. But because he lost part of his prefrontal cortex, he has a very hard time with higher order thinking, and especially with decision making. And so your prefrontal cortex is an extremely important part of your brain to protect. The next part is your parietal lobe, and your parietal lobe is right here, right where this blue is, right here in the middle. And this helps us process all of the information sent from our touch sensory receptors. Now, a lot of people think about touch as being your fingers. However, touch is all body sensations, all movement. So when we're talking about learning, when we think about using music and movement to learn, it actually, when you pair the music and the movement with what you're learning, it is going to go directly into your long-term memory. This area is also the area that helps us tell between left and right. Or left and right, sorry. You see a mirror of me, I'm sure. The next part is the occipital lobe. That's located in the back here, right here in the back. And this area helps us process all of our visual input that is sent through our eyes. It also helps us with color and depth perception. So I always suggest that if you have a student who is more of a visual learner, that you use lots and lots of color. Because the more color that you can use, the more the occipital lobe is going to be able to process that information, and especially in conjunction with music and movement and all of those all the sensory information that's coming through the reticular activating system. The key point is here is to make things as sensory rich as possible in order to get them through that reticular activating system, through the amygdala, and up into the upper brain. The next part is the temporal lobe. The temporal lobe is actually, it's part of the cerebral cortex, but it houses some of the functions of the lower brain. So it's the lowest part of the cerebral cortex. It's here. And this area helps us process all of our auditory information, anything sent from our ears. It also processes things from our nose, so anything that we smell. Lastly, Lastly, it has what's called the hippocampus. Let me open this up here. My brain comes apart. Okay. So we have the hippocampus. There's our little hippocampus there. And it's located in there, and that aids in storing memory. So it's like the file system for your memories, and that's your long-term memory. But it's also where the pituitary gland is located, and it's also where you have the like, for example, the hormones are secreted and where they come from. So for example, when you have, and all of you have relationships with your children because you're homeschoolers, but when you do things like read aloud, read stories, tell stories, share things that are common, it releases two hormones called dopamine and oxytocin, which aid in learning and retention in the brain. So the release of oxytocin and dopamine are very, very closely linked to memory. So anything that we can do in learning to release those two is going to help students retain, or learners, I should say learners in general, because we're all learners, right? We're all learners. Learners in general retain that information in the brain for a long term. That's why I always say, read aloud to your kids. It is so important. It releases the dopamine and the oxytocin. And in fact, what's really awesome about dopamine and oxytocin, this is super, super interesting. I could nerd out on this forever. What's really cool about dopamine and oxytocin is when it's released. So you two are having a common experience, and especially with reading aloud and telling stories, you and your child, or you and your children, are having common experiences. The brain, once it releases dopamine and oxytocin in both people's brains, their brains start to mimic each other and have the same patterns. So the brains start to play off of each other. It's like being telekinetic, right? It's so cool. I mean, when I found out about this, I was like, wow, this is amazing. I read to my kids. We have a lot of really of literature-based learning in our house. But I read to my kids aloud, and my kids are 12 and 7. I will read aloud to them until they are, you know, until they leave my home, because it's so important. And we read in French and we read in English. All right, so we talked about how learning is sensory. Now, what happens when you actually learn something? We talked about the different parts of the brain and which senses are linked to those different parts of the brain. Brain cells are called neurons, and you are born with approximately 100 billion neurons. When you learn a new skill, the brain accepts it from the reticular activating system. The new information goes up into the appropriate areas of the cerebral cortex. And then you grow in that area what's called a dendrite. And a dendrite, so you see your neurons, they're in blue. And the dendrites are these little points that come off. Now, when you grow a dendrite, that has to connect to something that you already know in order for you to actually learn and have retained the information. So the dendrites grow out of new neurons, and then when two dendrites grow close together, they form what's called a synapse. And a synapse is the contact point between the two dendrites. And the messages from one to another are sent by neurotransmitters. And as skills are practiced and reinforced, the synapses grow and grow and grow and grow, and more neurotransmitters are stored. Now, as the neurotransmitters are stored and everything grows and grows and grows and grows, this is when myelination happens. Remember, that's the word I told you about way earlier, myelination. That's when you grow what's called gray matter in your brain. That's the actual surface area. But what this gray matter does is it acts like a slip and slide for those neurotransmitters. So the more gray matter you grow, the more water gets put on the slip and slide, and the bigger the slip and slide gets, and the more connections your brain can make. And so then you have neurotransmitters going across synapses like zoom, 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 all over your brain. And they're going from, I took my brain apart, but they're going from this end to this end to this end to this end to this end, and the more surface area of your brain that you're using. Now, the only exception in this case would be the language center of your brain. And when you have neurotransmitters that are built in the language center of your brain, that part of your brain, actually, it's up here, kind of solidifies. There's two language centers of your brain. And I'll go back to this slide that shows them. There's two language centers. Oops, where did I go? One is called the Broca's area, and the other is called the Wernicke's area. And the Wernicke's area is in the temporal lobe, and the Broca's area is in the frontal lobe. And so those two areas kind of solidify as you get older. Now, the Broca's area is more responsible for second language acquisition, whereas the Wernicke's area is more responsible for like you being able to speak your native language and form words. Okay, so the Broca's area is in the prefrontal, and it's the the only area that really kind of solidifies. That's why like it gets harder as you get older to learn new languages. However, the younger you start learning languages, the more plastic your brain becomes, the more myelination that area has, the more your brain is primed, prepped, and ready to accept new languages as you get older. And so we can trick the brain actually into accessing that Broca's area in making connections to other parts of the brain through our senses. It's amazing. It's absolutely amazing. So when we grow dendrites, we grow our brains. And the way to best grow dendrites is to really apply what we're learning in a project or performance-based form. So when I say performance-based, I mean that we are taking the skills that we are learning and we are applying them in a real world context. So this could mean taking the skills and say we're learning language. This could be as big as going and visiting a country and immersing ourselves in the language and the culture. That's one way to do it. But we can also simulate situations. This could mean we're studying religion and a certain religion or world religions, and we go and we visit the different religious centers and we learn and we actually get to experience their experiences, how they worship whoever they worship. This could be a science experiment, applying what we've learned. So when I talk about performance-based learning in this context, I'm talking about the application of skills that we are learning in the brain in order to solidify those circuits, in order to keep growing those dendrites and to grow that gray matter to enhance our myelination. This could mean also taking things that we have already learned or crossing curricular skills. This could be cooking, where we're using math and reasoning and creativity. This could be an art project. This could be whatever you can think of. My go-to for teaching this type of brain-friendly way is literature-based. I do everything through literature, through books. I think about the interests that my children have. I think about types of books that will teach them culture and teach them skills, and we create a whole unit around literature or around a theme. And so the way that we need to think about this in order for our brains, that's friendly for our brains, is to think about planning not as individual subjects. And I feel like a lot of homeschoolers do this already. We need to think about themes and how things merge together, because we don't, in the real world, we're applying skills across the board. We don't have this math skill over here and this science skill over here. We're constantly merging things together and being in the real world and using the skills. They're not compartmentalized in our brain, and so we should teach them in a way that is not compartmentalized. As I finish up here, I want to suggest a book, and I do this with older kids. I've read this to my kids. This is called Your Fantastic Elastic Brain. Stretch it, shape it. And this book is amazing. I'm going to read it to you. It's a great way to explain neuroplasticity to your kids. And in fact, I suggest highly, and I always do this every year, my kids have done the neuroplasticity lessons over and over and over again, but I suggest doing them to refresh every time you start your school year. I don't know if you go year round, like some homeschoolers go year round, some homeschoolers take a summer break, but we always start our year with neuroplasticity. And then we do one with neuroplasticity, and we also do neurodiversity and setting SMART goals. So your fantastic, elastic brain. What does your brain really do? Does it fill the space between your ears? Well, yes, but your brain can do so much more. Your brain helps you think and remember and name what you see and what you hear. It lets you move your body and feel both touch and emotions. Your brain does all the things that make you you. So what is your brain? Is it a muscle? No, the brain is an organ in your body. It's made up of cells and tissue. The brain controls everything you do, everything you think, everything you feel, and even everything you dream. The brain has many parts that do all kinds of different jobs. The cerebrum, the cerebellum, and it explains in here what each of them does. Each of these, the prefrontal cortex, the hippocampus, the amygdala, and your neurons. When you were born, you were very little. Your brain was small and not so strong. As you get older, your body grows and gets stronger. As part of your body, your brain grows and learns to do new things. And you can make your brain do even more. Your brain grows very fast during the first 10 years of your life. This is the magic decade when you can help your brain grow faster and be more powerful. Just like lifting weights helps your muscles get stronger, learning new things strengthens your brain. You can give your brain a good workout by trying to learn many different things. Like elastic bands that stretch when you pull them, even things that are hard at first, or that you don't like to do, or that you don't do very well, get easier when you keep trying. Even when you make a mistake while you're learning something new, you are still training your brain. You will remember that mistake and try something else until you get it right. Making mistakes is one of the best ways your brain learns and grows. If you aren't willing to risk or be wrong, you won't take the chances that stretch your elastic brain. This is also called growth mindset. We talk a lot about growth mindset in our house as well. You can stretch the part of your brain that controls your feelings too. If you are frightened about taking a risk, like learning to swim, finding the courage to put your face in the water stretches your amygdala. It will remind you that you overcame fear. So you will be braver the next time something scares you, like diving into water. How does the brain stretch and grow? A word that begins with neuro has something to do with the brain. A sculptor molds and shapes or carves things out of clay, wood, or stone. So you shape your brain when you make it bigger by adding things you know and can do. You are a neurosculptor. When you learn something new, you're building on what you have already learned. In the same way that the muscles in your body work together when you want to lift a heavy object or kick a ball, the different parts of your brain work together when you're learning something new. That's something I want to learn how to do, is play the piano. My son can play the piano, and I want to learn how to do that too. Your brain, the brain that makes you you, really is an amazing organ. It controls what you think, do, feel, and remember. Your brain is growing very fast during your first 10 years of life, and now we know that you can help it grow. When you try hard to learn something new, connections grow from neurons and attach to other neurons. When your brain can send messages faster, making part of your brain bigger and stronger. Making mistakes really helps you learn because your brain keeps trying new things and stretching until you figure out the answer to your problem. You are shaping a more elastic brain when you learn new things that build on what you already know. So this is a great book to use. I do have some lessons plans written with this that go along with growth mindset and neuroplasticity.